Hi friends. So this is one question which is a sub-problem of the problem which we solved previously. Means if you see last two problems, we were solving this particular problem and then getting to our original problem. So let me read question for you and then you'll be able to easily figure out what we need to do here. Okay. So we need to find minimum in a rotated, sorted. We need to find minimum in a rotated sorted array. Okay. So, suppose an array of length sorted in ascending order, rotated between 1 and n times. Okay, no problem. Means some shifting will be there, left shifting will be there. Okay. For example, the array might become like this, rotated 4 times, rotated 7 times, and it's just stating whether that means how you'll rotate and what will be the output of that. It's just that. So, given a sorted rotated array nums of unique elements. Return the minimum element in the array. You must write an algorithm that run order of log n time. Now, instead of returning the index, we just have to return the minimum element in rotated sorted array. Okay, got it. So let's get back to notepad and then we'll solve it. Okay, so for example, what was the example? Let me check again. 34512. Okay, so yeah, the question is pretty clear, right? Let's say we have an array 3, 4, 5, 1, 2, and we have given this array. Now our task is to just find the minimum element, and that is this one. So how we can find it? One naive approach will be you'll be searching entire array and you'll be finding what is the smallest element, right? What else? We need to solve that in log n time, not n time, right? So we have seen like we can keep our left pointer here, right pointer here, and whenever uh, we search for mid, we look for one graph, right? And the graph could be like three ways. Graph can be increasing, strictly increasing. Okay. Next is the graph can be of this side will be increasing. Okay. And pose that here like this way. Unique elements. That's why in this particular line, I just put one element. Okay. So this one is y-axis and this one is x-axis. Okay, all good. So here, these two possible cases are there. Is there any other way to find, means any other possibilities? I think no, right? So what we are going to do now, let's say we have with case one, this one is case one, this one is case two. Let's see for case one, and we need to search for minimum element. What if we find mid element and that mid element is always smaller than the element which is at right? So we can shift our right to this index. Now our search space will be like this. Search space will be having this much section. Now this is right, this is left, and this one is mid. Again, you can shift your right to mid because you are always getting a number which is smaller than right element. So you keep on shifting towards the left index, right? Now here, now two possibilities in case two, right? In case two, let's say you are at this position and you are searching for one number that is at this point. Means let's say mid is this one is mid, this one is left, this one is right. Now you see that mid element is greater than right element, right? So what you need to do, you need to search in a rightward direction because the minimum element will be here in the right section. So in that case, you can move to rightwards. What will be the other case? Let's say you are at searching for right and mid is somewhere here. Now you know that instead of just a second, here let me change the color. You need to shift the left value to this point. That is not this point. Just a second. If I can erase, yeah. You need to shift this to mid plus one. That will be this index, I guess, right? Yeah, this index only. So you'll be shifting mid plus one in case one. In next case, if that element is smaller, then your aim is to search smaller value, right? So you can shift your right to mid only. Means this mid can be a smaller value, and overall, you'll means each time you'll be going towards the smaller value which is in the array. So this is the complete logic that we are going to utilize here. And yeah, that's it. We can code that out and see if that works or not. Okay, so yeah, let me keep my system closer. Okay, so we need to write an algorithm of login. So left and right is equal to left will be at 0 and right index will be at len of nums minus 1, right? So at this index, left and right is clear, while left is less than right. We are going to run our algorithm. Now each time we are going to find mid will be left plus right by 2. Okay, if nums of mid is greater than nums of right element, so what we are going to do, the mid element is greater means if you see your point is here and next point is here, so you need to shift your left to one ahead of mid. So left is equal to mid plus 1. Okay, else you need to shift your right to mid element. Now whatever at whatever index the left will be, that will be basically the minimum element. Okay, so what we can do here, we can just return nums of left and this will solve our problem. Yeah, I can run this and show you that this will work fine. All good, submitted, right? So the time complexity of this algorithm is log n because it's dividing search space into two every time, right? Yeah, that's it then. And what about space complexity? Space complexity is order of one. Okay, okay, see you in next problem.